Welcome back to the deep dive. Today we are taking on a subject that is, well, it's forcing a wholesale rethinking of how modern organizations even function. We're moving past the early excitement, the hype around large language models, and we're getting right into the hard engineering of really the new enterprise nervous system. Our sources have provided this incredibly comprehensive look at the fundamental shift from, let's call it, traditional linear automation.
The old scripted stuff.
Exactly, the kind that followed rigid scripts, to true autonomous agentic systems that operate with independent goals. We are looking at the birth of what our sources call the agentic enterprise.
Mm-hmm.
And here's the core takeaway that just immediately jumps off the page for me. The technical challenge, the ability to build the algorithms and the models, that's actually not the main constraint anymore.
Right. It's almost the easy part now, relatively speaking.
It is. The real problem, according to our material, is the organizational operating model itself. The historical structures we all use, how we handle IT architecture, how we organize product development, and critically, how we manage risk. They are just failing to accommodate these new, highly independent, goal-oriented entities.
That's exactly the mission for you, the listener, today. We're going to explore the comprehensive rewiring needed for organizations to support this hybrid ecosystem.
A hybrid ecosystem.
Yeah, we're talking about structures where humans and intelligent software agents aren't just working alongside each other, doing their own siloed tasks. They are cooperating as peers to achieve shared complex outcomes.
So it's not just another tool.
No, this isn't about bolting a new tool onto an old wagon. This is about structural, organizational, and even cultural evolution, really from the ground up.
And let's clarify that distinction immediately, because the difference between the old and the new is it's profound. Traditional automation relies on what we call deterministic processes.
Right. Rigid, specific if-then logic.
If the invoice comes in, then execute payment. It can't handle any ambiguity or, deviation from the script.
Agentic AI, in sharp contrast, uses what we call goal-oriented reasoning and independent execution. So you provide the agent with a high-level outcome, something like reduce inventory risk by 15% this quarter.
Okay, a big fuzzy goal.
Exactly. And the agent reasons through the necessary steps. It selects the right tools, it navigates unforeseen data obstacles, and it executes independently until that goal is met. This autonomy, this ability to choose its own path is incredibly powerful, but it requires an organizational foundation that is built entirely on managed trust.
Okay, let's unpack this structural evolution then. If the historical operating model was all about centralized control, linear workflows, top-down oversight, all designed for human limits, really, what does this new structural skeleton actually look like inside the enterprise?
Well, it's fundamentally built on distributed intelligence. The agentic operating model moves the firm away from the limitations of that traditional centralized command and control structure.
Right, the old hierarchy.
That old hierarchy was necessary because, human communication is slow and you needed sequential oversight just to ensure quality. The new model completely flips the organizational chart. It embeds agents directly into cross-functional, outcome-oriented units.
So the key shift for, say, a business leader is moving from managing individual low-level tasks like making sure Janine processes 50 invoices a day to managing high-level outcomes. Like ensure this entire business unit's quarterly budget is fully reconciled, audited, and optimized by the deadline.
Precisely. And this decoupling of the input, the task, from the output, the outcome, is what unlocks incredible scale. If the system is managing the outcome, the organization has to start treating the underlying autonomous software differently.
How so?
They're not one-off automation scripts anymore. They are reusable, governable, strategic assets. Our sources have a great name for them, the firm's cognitive assets. And the collective management of them is called the cognitive portfolio.
That's a provocative label. What's the biggest practical difference for, let's say, a CFO? Between managing traditional software licenses, which we're all used to, and managing these new cognitive assets?
The difference is immense. Traditional software is static. You buy a license, it performs a fixed set of functions, and that's it. A cognitive asset is dynamic. It learns, it adapts, and critically, it possesses agency, the ability to choose an action.
Okay.
So managing a software license means you're managing installation and renewal dates. Managing a cognitive asset means you're managing its training data, its version lineage, its policy adherence, and its capacity to fail gracefully.
It's a living thing, almost.
In a way. And this cognitive portfolio isn't just a list of agents on a spreadsheet. It requires a foundational platform. This platform acts as the governance layer. It manages agent dependencies, making sure Agent A doesn't accidentally break Agent B. It handles all their telemetry, and most importantly, it enforces organization-wide policy in real time.
So we're building a governance framework around the potential for independent action. The platform manages the constraints, the rules of the road, so to speak. So the agent can just focus on driving toward the goal without the risk of, major noncompliance.
Exactly. This organizational skeleton provides the stability for agents to operate with high agency, to perform specific actions like updating a database or releasing funds, while ensuring they remain tightly aligned with the strategic intent of human leadership and legal mandates. If you don't build this structural oversight, autonomy quickly devolves into expensive, unauditable chaos.
Which is probably why so many of these early pilot projects just stall out.
It's often the reason. They prove the tech works in a sandbox, but they can't scale it because the organizational scaffolding isn't there.
And the economic value of framing these as assets, what's the payoff?
It allows for enterprise scale and, crucially, asset reuse. So instead of rebuilding a bespoke accounts payable automation solution for every single regional office, you develop a single invoice reconciliation agent. You treat it like a cognitive asset. You version it, you govern it centrally through the platform, and then you can deploy it across dozens of business units. The local configurations, like currency or local tax rules, are just managed through parameters, not by rebuilding the entire logic stack from scratch. The standardization allows the marginal cost of deploying a new capability to drop dramatically down toward the cost of compute. And that, at the end of the day, is the ultimate strategic prize of this entire transformation. So if the operating model is the structural skeleton that defines the firm's philosophy on distributed intelligence, then the agent mesh is the technical nervous system that makes all that real-time coordination possible.
Nervous system, I like that.
Yeah, and this infrastructure is absolutely critical for moving beyond siloed pilot projects into a functioning unified enterprise.
So this is the infrastructure that lets all the individual cognitive assets we just talked about actually cooperate and work toward those big end-to-end outcomes.
Yes. It functions as a secure, policy-driven network that's essential for agents to work cohesively. The common failure point for early AI adoption is what I call the silo trap.
The silo trap.
You have a great marketing agent over here, great security agent over there, but they don't talk to each other in a unified, governed way. The agent mesh transforms these fragmented local successes into a unified intelligence supply chain.
An intelligence supply chain.
It ensures that the output of one agent becomes the trusted, policy-vetted input for the next agent down the line.
That concept, an intelligence supply chain, implies there has to be some kind of control tower. What is the operational role of this mesh?
It serves as the cognitive control plane. It manages the critical infrastructure for all autonomous systems in one centralized yet policy-enforced layer. This control plane is what bridges that massive gap between raw, siloed data and production-ready actions.
And how does it do that?
By centralizing the management of identity, permissions, cost monitoring, and observability, it ensures that all agents adhere to a unified set of organizational principles, while still retaining the flexibility to perform their domain-specific tasks.
This sounds vital. Okay, here's where it gets really interesting, because the mesh isn't a single piece of software, right? It's composed of several essential, specialized components that manage the fundamental requirements of autonomy. Let's dig into the engineering of this control plane.
Absolutely. We have to begin with the identity broker. When humans log into a system, we use, biometrics or passwords. Agents, especially when they're interacting with external systems or sensitive databases like an ERP, they need unique, verifiable machine-based identities.
And the identity broker handles that.
It manages the entire life cycle and validity of these credentials.
How does that differ from traditional application identity management? I mean, we've had service accounts for years.
That's a great question. Traditional systems often use those generic shared service accounts. The identity broker assigns unique, non-human, verifiable credentials to every single agent instance.
Every instance. Wow.
And its impact is twofold, and is foundational to security. First, it prevents unauthorized system access by ensuring only policy-vetted agents can even attempt an action. And second, it ensures granular auditability. If an agent executes an unauthorized action or causes an error, you know exactly which machine identity tied to a specific agent version and owner did it.
Which is essential for forensics and preventing, say, lateral movement across the network if one agent gets compromised.
You've got it. Then you need the gatekeeper, the technical manifestation of that trust architecture we talked about, the policy enforcement point. This is where your policy document becomes living code.
Okay, so it's the enforcer.
Precisely. This component validates every single attempted agent action against real-time governance APIs. Imagine a financial agent that decides to execute a high-value transfer. Before that transfer API is even called, the policy enforcement point intercepts the request. It checks multiple governance sources simultaneously. Is the amount within the delegation charter limits? Is the vendor on a compliance watch list? Is the action congruent with the current system state? All in milliseconds.
This is a radical departure from the old way of doing compliance. I mean, I'm used to compliance officers doing a human audit once a quarter, maybe. How does this thing technically achieve that real-time validation?
It typically operates through an architecture of microservices or dedicated API gateways that are integrated directly into the agent mesh. When an agent attempts an action, a lightweight microservice endpoint configured with the current policy rule set gets called.
Okay.
It verifies the request against all those governance APIs and just returns a simple allow or deny in milliseconds. The impact is profound. It dramatically reduces the risk of policy violations because the guardrail is applied at the point of action, not weeks after the fact.
In a high-speed autonomous environment, that immediate enforcement is really the only thing that works.
It's the only thing that scales. Moving on to the architecture that enables complexity, the shared memory layer. This solves the problem of sequential, multi-step problem solving, which is, the hallmark of any complex business process.
Right, things that take more than one step.
If an agent is tasked with a complex process, say a vendor procurement cycle that takes 3 days and involves talking to ERP systems, external market data feeds, and internal legal review systems, it needs perfect memory.
It can't have amnesia between steps.
Without that shared memory layer, it would. It would struggle with context, forcing it to restart, or worse, make decisions based on outdated initial input.
So technically, what is this memory layer? Is it just a big database?
It's typically a high-speed, specialized store, often a key-value store, or more commonly now, a vector database that's dedicated to preserving the agent's working context. Sometimes you'll hear this called the RAG context, for retrieval augmented generation.
Oh.
By persisting this context and state, this layer enables that long-horizon problem solving. And crucially, it allows for sophisticated cross-agent collaboration where, for example, the procurement agent can hand off the task seamlessly to the legal agent, knowing the full history and previous decisions are instantly preserved and available.
Next, for mandated transparency, we have the observability sync. When an agent makes a decision, choosing a logistics route, denying a loan, we absolutely need to know why. No exceptions.
The sync is the forensic record keeper. It aggregates application logs, system telemetry, and the agent's internal workings. But its most unique function is aggregating and storing the agent's reasoning traces. We often call this the agent's chain of thought.
The chain of thought.
So instead of just logging the outcome, like loan denied, it logs the entire sequence of logical steps, the policies it consulted, and the data inputs it weighed to reach that outcome.
And this reasoning trace is essential for way more than just troubleshooting, right?
Absolutely. The observability sync provides transparency into those, black box decision-making processes, which is vital for satisfying regulatory requirements. If a regulator asks, why was this specific transaction routed this way? You can't just say, the AI did it. You have to be able to retrieve that reasoning trace.
Right.
And these traces are critical for human supervisors to debug and fine-tune the agent models, ensuring trust by demonstrating explainability. In high-stakes environments, that is a fundamental requirement.
Okay, finally, we need the ultimate financial safeguard, the resource coordinator. Autonomy isn't free. Every API call, every calculation, every token generated consumes compute resources and costs real money.
The resource coordinator is a central budget and control mechanism. It allocates compute budgets, it manages API throttling limits, and it dictates token consumption across the entire cognitive portfolio. This component integrates deeply with cloud cost management platforms to give you real-time visibility into the operational expenditure of the entire agent mesh.
Can you describe the kind of failure it's designed to prevent? What's the nightmare scenario here?
It's designed to prevent the runaway agent scenario. Imagine a poorly designed agent gets stuck in some kind of recursive loop trying to re-optimize a logistics problem by constantly calling an external expensive model API.
Oh boy.
Without limits, That agent could, in a matter of hours, generate millions of dollars in unexpected compute costs. The resource coordinator manages this operational risk by implementing automated execution caps and, soft or hard kill switches based on predefined budget thresholds. It's the ultimate financial safety net for scaled autonomy.
So all this pieces together, the identity broker, the policy enforcement point, shared memory, the sync, and the coordinator. That's the agent mesh. That's the technical prerequisite for doing any of this at scale.
That's it. It's truly the nervous system.
So we've established the structural skeleton, the operating model philosophy, and the nervous system, which is the agent mesh infrastructure. But organizations don't just, flip a switch and implement these uniformly. They have to make a conscious choice about their operating structure.
That's right.
Which is essentially a decision about balancing two critical forces: enterprise-wide consistency against local-level agility.
And that decision really dictates where authority resides, how intelligence is managed, governed, and deployed throughout the entire enterprise. Our sources identify three primary operating structures that organizations typically gravitate toward, based on their regulatory environment, their cultural maturity, and of course their business needs.
Okay, let's start with the centralized model. This seems like the natural starting point for a lot of organizations, I would imagine.
It is. In the centralized model, all agent development, deployment, decision-making, and tool selection reside under a single dedicated governing body. This is often housed within the CTO's office or a dedicated AI center of excellence.
And the strength there is obvious.
Maximum consistency, standardization, and simplified auditability. For a highly regulated financial institution, for instance, where every compliance action has to be identical across all jurisdictions, centralization is highly effective. It ensures every single agent adheres to the exact same security and ethics standards.
But I see a problem. If all capability requests have to flow through one single central team, that sounds like a recipe for the exact bottleneck the agent mesh is supposed to solve in the first place.
That is the primary risk. As demand for agentic capabilities accelerates across the business, marketing wants an agent, HR wants one, supply chain needs 5, the central team's capacity is just quickly outpaced.
A huge bottleneck.
A huge bottleneck, and then it slows down innovation. So its best use case is typically in those highly restricted environments, or during the initial foundation building phase rung 1 of the roadmap, which we'll get to later, where those crucial foundational standards, like the design of the identity broker, are being set in stone.
Okay, so moving to the complete opposite end of the spectrum, where speed is the top priority, we find the federated model.
This model radically decentralizes decision-making and ownership. The business units themselves become the primary domain leaders. They own their specific agents, their maintenance, their deployment, while they still have to adhere to organization-wide policies that do not cross lines. They control the architecture and customization of their local intelligence supply chain.
So the strength is pure speed.
Explosive agility and rapid innovation. Local teams who have deep domain expertise, a supply chain unit knows logistics better than the central IT team ever will. They can tailor and deploy agents much faster to gain a competitive advantage.
That decentralization, though, it sounds like it introduces the major risk of what our sources call governance drift.
Absolutely. The weakness is a very high risk of inconsistency. If standards aren't enforced diligently and continuously through that policy enforcement point we talked about, you can end up with incompatible agent systems, inconsistent data governance, and fragmented application of ethical guidelines across the whole organization.
So where does this model work best?
It's best suited for high-growth, high-variability markets. Think of a multi-brand technology conglomerate where rapid adaptation and leveraging local domain expertise is absolutely crucial for survival.
Which brings us to the middle ground, the structure that most organizations seem to be aspiring to as it aims for that necessary balance. The hybrid model, or the hub and spoke approach.
This model seeks balanced scale. The central body, the hub, is responsible only for the foundational shared resources. This includes the core agent mesh infrastructure, the standard technology stack, and the overarching legal and ethics frameworks.
So it centralizes the things that must be consistent.
Exactly. And the spokes, the local agent pods in the business units, they develop the specialized outcome-focused capabilities, like building a specific regulatory filing agent for a local market or a novel, highly tailored marketing automation agent.
The strength seems to be optimization then. You get centralized control where it matters most, like security and auditability, combined with localized specialization where domain nuance is key.
That's the goal. The primary drawback, however, is complex coordination. Managing the interfaces between the hub, which is the central infrastructure team, and all the spokes, the business unit developers, and ensuring communication across all the different agent pods. It requires really robust organizational processes and clear service-level agreements.
So what's the ideal use case for this hybrid model?
It's ideal for large, complex organizations that are transitioning from an old, centralized baseline. It allows them to build those centralized foundations and then gradually mature their workforce toward higher agentic literacy and more localized autonomy over time. In this new era of autonomous execution, trust. Well, trust can no longer be a reactive mechanism. If an agent can execute a multi-million-dollar transaction in milliseconds, auditing that action 3 months later is, frankly, pointless.
It's too late.
Way too late. Trust has to be treated as infrastructure, a core service of the enterprise. We call this trust by design.
That means governance must be embedded directly into the cognitive fabric, integrated right into the agent mesh components we just detailed. So policies are not passive documents in a binder somewhere. They are active APIs that are checked in real time.
Exactly. This robust trust architecture replaces reactive compliance, the traditional model of periodic human audits, with proactive, real-time validation. When governance is embedded into the policy enforcement point, the system gains the ability to autonomously monitor its own policy adherence, self-correct minor deviations, and crucially, escalate issues the moment they exceed predefined safety and cost thresholds.
This is compliance at the speed of AI.
It has to be.
Yeah.
And so, if we're going to delegate autonomy, we need a really precise mechanism to define the legal and technical boundaries of that delegation. That's where the delegation charter comes in. It's the formal contract of autonomy.
The contract.
The charter defines the operational contract between the human governance layer and the autonomous agent. And it clearly distinguishes between two core concepts, agency and autonomy.
Agency and autonomy. Let's break those down.
Agency refers to what the system is permitted to do, the full catalog of actions it has the capability to perform. For example, the ability to read customer data, the ability to submit a purchase order.
And autonomy.
Autonomy is the degree of independent decision-making allowed within that agency, without mandatory human intervention.
Okay, let's use a really granular example to illustrate that distinction.
Perfect. Consider a procurement agent. Its agency is broad. It can interact with the vendor database, it can initiate contract review flows, and it can submit purchase orders, or POs.
Okay.
Its autonomy, however, is constrained by the charter. The charter might permit the agent to autonomously approve and submit POs up to, say, $5,000 for verified low-risk vendors. That is its zone of operation.
But what if a PO is for $6,000?
Then that condition triggers an escalation, a required human-in-the-loop pause. Or if the vendor's risk profile rating shifts from green to yellow, same thing. The charter is like a dynamic throttle, allowing the organization to increase autonomy only as confidence in the system's performance and accuracy matures.
So let's delve into the specific engineering requirements of these charters. They have to translate abstract policy into something executable, a technical contract.
They absolutely must be measurable and enforceable by the agent mesh. Our sources highlight 5 major components. First, scope boundaries. This is the mapping of the agent's allowed tasks directly to the system's access control lists and identity-based permissions, which are managed by the identity broker.
So it literally can't see or touch data that's outside its mandate.
Exactly. Second are decision thresholds. These are quantifiable, hard-coded constraints for autonomous action. Financial limits, like the $5,000 PO maximum, or operational rates, like no more than 10 executions per minute. These are the hard barriers enforced by the policy enforcement point that the agent just cannot cross, regardless of what its underlying model thinks.
Okay, what's third?
Third, escalation triggers. These handle the qualitative or, fuzzy conditions that the hard thresholds can't capture. If the agent detects high ambiguity in the input data, or it encounters a novel scenario it hasn't been trained on, these triggers initiate exception handling logic, diverting the task to a human supervisor for manual review.
Got it. What's number 4?
Fourth, and this is a big one, the reversibility mandate. This is a non-negotiable requirement for any high-risk operation. The charter must require that all agent actions be reversible or somehow compensable.
And that's not just a policy, that's a technical requirement.
Yes, it requires technical support through automated rollback pipelines, state snapshots managed by the shared memory layer, and transaction logs that ensure if an error occurs, the system can quickly revert the change and restore a known good state. It's fundamental to resilience.
And finally, the 5th component.
The audit requirement. This specifies the required level of logging and justification for every decision. For a minor task, maybe just a transaction log is needed. But for a high-stakes decision, It mandates the immutable storage of the agent's full chain of thought in the observability sink, ensuring the complete rationale is available for forensic review years later.
This entire structure, it forces a really foundational change in how we think about risk. We have to ask, who is responsible when an autonomous agent operating perfectly within the technical limits of its charter causes a costly mistake?
And that's the key question. Accountability has to shift from following human instruction to following the system design. An agent may execute the action, but a human must remain legally and organizationally responsible for the outcome.
So you can't blame the bot.
You can't blame the bot. This responsibility is tied to the owner of the business process and the human who signed off on that agent's delegation charter. You can automate the action, but you cannot delegate accountability.
And this necessitates a complete evolution of segregation of duties, or SOD. Traditionally, SOD prevented fraud by dividing manual tasks among different people. The person who approves the payment is different from the person who sends the check. If the agent is now doing all those steps, how do we maintain controls?
Agentic SOD moved the focus from segregating manual execution tasks to segregating access privileges and system configurations. The goal is the same: prevent a single point of failure or malicious access. For instance, the human responsible for configuring the agent's decision logic, the policy author who sets that $5,000 threshold, must be organizationally and technically separate from the human who manages the agent's machine identity and its access to the core financial systems.
So the risk moves from a human colluding to process a fake invoice to a human configuring the agent to bypass a compliance threshold.
Exactly. If the policy author, who sets the rules, can also control the identity broker, which grants access, they could configure an agent to execute transactions outside its charter, effectively bypassing all controls. The new SOD is all about technical and organizational segregation to prevent unauthorized system configuration.
Our sources provide a really useful table that illustrates how these traditional duties shift. Let's walk through that functional transformation.
Okay, starting with the classic control point, authorization. Historically, a manager signed off on something. That duty now shifts upstream to policy definition. This is the domain of the policy author, the legal teams, the compliance leads, who rigorously define the rules inside the delegation charter.
Okay, and custody, the safe handling of assets or credentials.
That's now credential management. This is handled technically by the identity broker and the secure vaults within the agent mesh, ensuring all non-human access is tracked and protected.
Execution, the manual task itself.
That becomes agent autonomous action, performed entirely by the agent within the boundaries defined by its charter and the policy enforcement point.
What about the often overlooked but critical duty of record keeping?
That becomes immutable logging. It's automated entirely by the agent mesh and the observability sink. And since the log includes the chain of thought, it's far more comprehensive and reliable than any manual record could ever be.
Finally, the crucial control of reconciliation, the cross-check to ensure accuracy.
This is transformed into validation agents, and this is fascinating. This is often performed by a secondary agent, a critic bot, whose sole function is to audit the primary agent's action and review its reasoning trace against a secondary set of logic.
So you have bots checking bots.
You're building a powerful, machine-supported system of checks and balances right into the intelligence supply chain. So with the agents taking over all this high-volume execution, the fundamental nature of human work just shifts dramatically. It moves from functional task performance, actually doing the work, to system orchestration.
Managing the autonomous entity that does the work.
Right. And this necessitates a workforce that has moved beyond basic digital literacy and has achieved what we call agentic fluency.
This is a crucial distinction. For a while, we've all been focused on the skills needed for early AI adoption, which was mainly prompting.
Yes, the initial skill was prompt engineering,
Yeah.
mastering the art of command and response. You input a perfect prompt, you get a desired output. But as systems become autonomous and execute across the enterprise, the focus is shifting entirely to agent engineering.
What exactly is agent engineering, and how is it different from just writing good prompts?
Agent engineering is about designing the architecture of problem-solving itself. You are not just telling the agent what to do, you are defining its entire operating system. You're setting its goals, defining its policy constraints, selecting the tools it can use like API access, and managing the complex interactions between multiple agents in a mesh.
So the human-AI relationship changes.
It shifts from command and response to one of partnership and co-discovery. The human strategic value lies in specifying the ethical, legal, and reasoning protocols the autonomous system must use, ensuring alignment with organizational values before a single action is ever taken.
That sounds like it requires really specialized hybrid roles. Our sources describe a new skill ladder that's necessary to manage this complex cognitive portfolio.
We see two core high-value profiles emerging that really define the future workforce. First, there's the M-shaped supervisor.
The M-shaped supervisor.
The M signifies a broad, multi-domain fluency. These individuals are generalists who are experts in AI orchestration. They manage the hybrid workforce, balancing human intuition with machine efficiency across multiple, typically cross-functional domains. They are the friction resolvers.
So they're making sure the different agents' goals don't conflict.
Exactly. They ensure the marketing agent's goals, like increasing customer engagement, don't conflict with the financial agent's cost constraints or the legal agent's compliance mandates. They manage the whole portfolio.
And then there's the complementary role, the T-shaped expert.
The T-shaped expert brings deep specialization, say, in highly nuanced legal contract language or exotic financial derivatives, combined with the crucial ability to encode that deep knowledge into the agentic systems.
So they're the subject matter expert.
They are, and they handle the complex exceptions that agents can't resolve, the 1% scenarios that require deep human judgment. And they are responsible for continually refining the agent's domain relevance. They gain influence not by doing manual tasks, but by ensuring the agents accurately reflect the nuanced reality of their specialized domain.
And we're also seeing entirely new roles appearing that reflect the dedicated management required for these autonomous systems. Can you detail some of those emerging positions?
Certainly. We need the agent coach, who is focused not on training employees, but on training and guiding the agentic capabilities, managing feedback loops, and encoding institutional knowledge into the agent's persistent memory layers.
Okay.
Then you need the intelligence orchestrator, who's responsible for designing the cross-functional agent meshes, managing the data flow, and managing resource allocation via the resource coordinator across the entire network.
And a really crucial one.
And, crucial to the trust architecture, the epic steward. This role is dedicated to ensuring value alignment, continuous compliance mapping, and societal risk assessment as these autonomous systems evolve. Their job is to bridge that massive gap between abstract corporate values and the binary logic of the agent mesh.
To operate at AI speed while still maintaining strategic control, organizations need very clear definitions for how humans interact with the autonomous systems. This is the definition of the loop models.
Right. And these frameworks define the governance level required for every agentic process, which should be explicitly mapped in that delegation charter we talked about. The most restrictive is the classic human in the loop.
So a human has to approve everything.
It requires explicit human review and approval before any action is executed. It is absolutely mandatory for high-risk, irreversible transactions or novel tasks where the system's uncertainty is inherently high.
Then we move to a higher degree of trust with human on the loop.
This involves continuous monitoring by a human supervisor. The agent acts autonomously and executes actions independently, but the human retains the ability to intervene or hit the kill switch to override the system in real time if they detect drift, an anomaly, or a policy violation.
Like a supervisor watching a dashboard.
Exactly. They have the authority to pause the automation immediately.
And the ultimate goal, which reflects the highest level of maturity and trust, is human above the loop.
Here, humans move entirely to strategic oversight. They are no longer monitoring individual actions or real-time performance. They focus on defining high-level goals, auditing system-wide performance, and reviewing output only by exception.
Management by exception.
Right. They manage the entire cognitive portfolio, adjusting parameters and charters based on systemic safety and efficiency metrics. This level of maturity is what allows the enterprise to truly operate at exponential scale.
And linking this all back to leadership success, our sources highlight a really compelling new leadership metric. Leaders are now evaluated not on their traditional span of control, how many people report to them, but on their span of cognition.
The span of cognition. It's the volume and quality of distributed, complex decisions they can effectively govern across the agent mesh. A successful leader can define the strategic goals and constraints for hundreds of autonomous agents operating across multiple domains, ensuring all those automated decisions are aligned and compliant without needing to manually approve a single transaction.
So it reframes leadership entirely.
It reframes leadership as being a governance architect rather than a process manager. As systems transition to full autonomy, they introduce entirely new failure modes that traditional monitoring systems, which were designed for rigid deterministic automation, are guaranteed to miss. Organizations have to develop a new operational taxonomy of these agentic risks.
What happens when the system breaks down in a uniquely AI way? Let's examine this taxonomy of agentic failure.
One of the most immediate concerns is black box blindness. This is when an agent reaches a decision, but the reasoning is completely opaque, making troubleshooting or regulatory justification impossible.
And the remediation for that.
It's structural. You have to mandate robust chain-of-thought logging for every complex action stored in the observability sink and force the agent to output its rationale before it's allowed to execute.
We also face failures that are rooted in data quality, which is magnified by autonomy. Our sources call this siloed context and bad decisions.
This is when agents act on incomplete, fragmented, or outdated information from siloed data environments. This leads to illogical or non-optimal outcomes, even if the agent's logic itself is perfectly sound.
For instance, a procurement agent might buy materials at an old price because the latest contract data wasn't instantly available from the legal system's silo.
Precisely. And the fix here is structural and involves massive data governance efforts. You have to move to low-latency, retrieval-ready data platforms that ensure agents are grounded in the enterprise's true, real-time state.
A critical human factor risk is automation bias.
This is the tendency for human supervisors, the human on the loop, to over-rely on and blindly accept illogical or incorrect output simply because it came from a sophisticated autonomous system. It completely undermines the last line of human defense.
And how do you mitigate that?
In high-risk scenarios, organizations have to mandate dual control for high-risk nodes, forcing two different agents or even two different human supervisors to independently validate the rationale and the proposed action.
And what about performance failures within the mesh itself, like looping behavior?
Looping behavior is when an agent just gets stuck in a cycle of repetitive actions without making any progress toward its goal. It might continuously adjust a parameter, fail, reset, and try again over and over because it failed to recognize the constraint as permanent.
Wasting time and money.
And the remediation requires those automated execution caps we talked about, kill switches triggered by pattern recognition of repetition and the reasoning traces, and using the resource coordinator to limit the runaway cost.
Finally, there's a really scary one associated with memory and learning, memory poisoning.
This is a complex failure mode where exposure to specific, usually flawed or adversarial, inputs causes the agent's persistent memory state, its vector database context, to diverge, leading to highly unreliable and often biased behavior thereafter.
It's like a software virus for the agent's brain.
That's a great way to put it. The solution is strictly technical. Mandatory procedures for a memory state purge and rebuilding the agent's vector database from verified source data to restore a known good or clean state. Since failure is not a possibility but an inevitability in any complex high-speed autonomous system, the organizational pivot has to be from a prevention-centric model, trying to stop every failure, to a resilience-centric model.
Okay, so what is resilience in this context?
Resilience is the system's ability to maintain critical functions even under failure conditions, recover rapidly, and, crucially, learn from the experience to prevent it from happening again.
That means incident response fundamentally changes. I mean, how do we treat an incident when the person who caused the failure is autonomous code operating within the agent mesh?
It requires specialized, engineering-focused incident response playbooks. These playbooks need a technical sophistication that goes far beyond traditional IT recovery. For example, the playbook must detail how to conduct a canary deployment for agents, testing a new agent version on a tiny segment of the workload before you scale it. It must include detailed steps for rolling back a specific agent to a previous verified version via the cognitive asset platform. And critically, it must detail how to isolate a single misbehaving agent or purge a poisoned memory state while allowing the rest of the mesh to continue critical functions without interruption.
So you're minimizing the blast radius of the failure.
Exactly. Failure is treated not as a catastrophe, but as a continuous source of information that immediately drives the adaptation of the trust architecture itself.
Okay, finally, let's talk success metrics. When the work is distributed and highly automated, traditional task completion metrics are pretty much meaningless. We have to prioritize joint impact, systemic outcomes, and most importantly, the trust we actually place in these systems.
We need metrics that assess safety, reliability, and business impact, all at the same time. Starting with safety and reliability, the single most essential indicator of earned trust is the disengagement rate.
This is the frequency of human interventions required to correct or take control of the system. So if the agent makes a mistake and a human-on-the-loop supervisor has to hit the override button, that counts as a disengagement.
Exactly. If your agents are constantly requiring a human to step in, you fundamentally do not have a high degree of autonomy, regardless of what the code is capable of. A high disengagement rate indicates poor training, flawed policy design, or just insufficient grounding data.
And then the classic indicators still apply.
Yes, but applied to autonomy. We track mean time between failures, MTBF, specifically focusing on the average time before a policy breach occurs, and recovery time, how fast the system returns to normal after a failure, which really tests your resilience playbooks.
And looking at efficiency, how do we prove the investment is worthwhile?
We have to compare the cost and speed of autonomous execution against the traditional processes they replaced. This means focusing on resource utilization efficiency, optimizing the consumption of compute, tokens, and human attention, and, critically, total cost of ownership, or TCO.
Yep.
TCO needs to rigorously compare agent operational costs, the compute and token expenses managed by the resource coordinator, against the traditional expenses of human labor, licensed enterprise software, and infrastructure maintenance. This metric is what proves the economic value unlocked by true autonomy.
And the beauty of the system is that it's a closed-loop governance cycle. The metrics inform the delegation.
That's the most sophisticated element. If your autonomy metrics show a sustained low disengagement rate across the portfolio, the logical management response isn't just to celebrate the success. The strategic response is to increase the delegation charter thresholds for those high-performing agents.
You give them more autonomy.
You grant them more autonomy and agency. It's continuous improvement driven by validated trust. Transitioning to a fully agentic enterprise is not a single IT project. It's a disciplined, staged, multi-year organizational journey. It involves 5 defined rungs of maturity, requiring a disciplined balance between innovation and managing operational risk.
Let's start at the beginning, rung 1, which sounds like building the infrastructure and getting the whole organization on the same page. Rung 1, foundation and strategic alignment.
This is all about readiness. The organization has to establish the initial governance environment, which means aligning stakeholders, IT, legal, compliance, business leadership, on a unified vision for agentic AI. You also conduct a crucial audit of your data ecosystems, categorizing data sources for quality, latency, and sensitivity.
Because agents can't operate on garbage data.
They cannot. This is also where the central virtual control tower is established. This central body defines the initial reference architecture, chooses the foundational frameworks for the mesh, and sets the baseline ethical and security controls. This is the bedrock of the entire enterprise.
Okay, moving to rung 2, pilot or prescribed agency.
Here, organizations launch their first fully end-to-end agentic processes, but only in lighthouse domains. These are strategic areas that typically already have high data maturity, like IT incident management or back-office finance reconciliation.
And the agents here are on a tight leash.
Very tight. They often operate in a shadow mode, executing actions but requiring manual confirmation, or they operate with highly restricted supervised autonomy. The goal here is organization-wide learning, building the organization's learning muscle, and validating the agent's reasoning traces against known outcomes to build that initial pool of organizational confidence.
Then we escalate significantly at rung 3, orchestration or supervised agency. This is where the real complexity kicks in.
This is the transition from individual agents to multi-agent systems. Individual cognitive assets are connected into sophisticated systems that handle complex end-to-end business outcomes that span multiple domains.
Like a full customer onboarding process.
Exactly. One that involves marketing, legal, finance, and logistics agents all working in sequence. This requires the full, integrated deployment of the agent mesh for secure, policy-driven cross-domain coordination. And operationally, this is incredibly challenging.
Why is that?
Because you're connecting legacy systems with high-speed autonomous systems. Talent transformation accelerates here, shifting the workforce into those M-shaped supervisors and T-shaped experts needed to handle the increased complexity.
Which moves us toward the ultimate goal of independence, rung 4, adaptation or guarded autonomy.
At this level, the systems start to gain sophisticated learning loops and robust self-correction capabilities. The focus of the human workforce shifts entirely to management by exception. The agent mesh becomes sophisticated enough to autonomously monitor its own policy adherence and adjust resource allocation based on real-time loads.
So the system starts improving itself.
The system is improving itself, and human effort is reserved only for critical policy resets or those really complex domain exceptions.
And the final stage, rung 5, transformation. or full enterprise agency?
This is the destination. The enterprise redefines itself around autonomous, outcomes-focused networks. Traditional organizational hierarchy charts, those old boxes and lines, they're replaced by dynamic work charts based on human-agent team exchanges and the efficient flow of outcomes.
And the economic impact?
Critically at this stage, the marginal cost of execution, the cost of performing one additional transaction or reconciliation, begins to fully decouple from growth. It approaches the cost of compute itself, enabling exponential scalability and fundamentally changing the economic calculus of the entire organization.
What a detailed roadmap and architectural blueprint. We've covered everything from the organizational philosophy to the nuts and bolts of the cognitive control plane. So, what does this all mean for you, the learner, moving forward?
I think this deep dive shows unequivocally that deploying agentic AI successfully is less a technology challenge that you can just buy off the shelf and far more an organizational governance and trust architecture challenge that you have to engineer from the ground up.
The foundational point remains that the primary failure mode of the next decade will not be the lack of artificial intelligence capabilities. I mean, those are rapidly accelerating. It will be the presence of legacy organizational thinking, old hierarchical silos, outdated compliance processes, human-centric capacity constraints that attempts to constrain these autonomous systems within structures designed for the limitations of the past.
Right.
Success belongs to those who treat trust as infrastructure and manage outcomes, not tasks. We've discussed how, in the final stages of maturity at rung 5, the marginal cost of execution moves toward the cost of compute. This means the friction and the expense of doing complex work just drops dramatically, creating massive new opportunities. So consider this final provocative thought for your own organization. If the cost of execution approaches zero, and human roles are elevated entirely to the governance of this distributed intelligence, defining the strategic goals and ethical boundaries, managing the span of cognition, what strategic goal, currently deemed impossible or just too expensive due to operational complexity, could an unconstrained yet fully governed agent mesh solve? The focus shifts entirely from how to do the work cheaply and efficiently to what strategic intent is truly worth governing at enterprise scale.